Hello everyone, in this course I'm going to talk about an important matter in Java development, and that is unit testing. I'll begin by discussing what unit tests are and why do we use them. Then I'll present you some simple techniques, then continue by showing you some more advanced ones. I'll discuss about some tips and tricks that you can follow, and also I want to show you some bad practices that I think you should really avoid. Let's get to it. What is a unit test? A unit test is a piece of code which aims to test the logic inside one unit. By one unit, we basically refer to the smallest block of code that has a logic of its own in it. So in Java development, by unit, we understand method. Unit tests contain different checks, different assertions that make sure that each component of the code works as expected, and we won't get to see any unexpected behaviors further down the line. This is only possible by testing each and every method in an isolated manner. It's very important that we do it in an isolated manner. I will discuss about this further on. So why do we create and why do we use unit tests? Basically, the most important and simple part to get is that by having unit tests, we make sure that the code works as expected. Also, we get to verify the quality of the code, and we get to see if the quality meets the required standards before deploying or releasing it. So unit testing can help improve code quality by ensuring that each method of code is functioning correctly and as expected. Clearly, this helps to prevent errors or unexpected behaviors in the long run. While unit testing, there's a big possibility that we can discover bugs. So besides ensuring the standards uh, are ensuring that the standards are continuously met, by writing unit tests, we can also discover bugs, errors, or distractions that can be fixed before they spiral out of control. So imagine this. If block of codes are unit tested well, right? When developers will make changes on a functionality, the unit tests clearly will fail. This is either an expected scenario or an unexpected one. Let me get in detail. So there are times in which a developer will change a functionality and he'll know that the unit tests will clearly fail because the functionality is going to be changed. So he's going to change that functionality, right? Unit test will fail and he'll have to change the unit tests accordingly to the new functionality. But it also happens that sometimes developers can modify a logic in the code by mistake without them realizing it actually. So the unit tests will fail, and this will tell them that they broke something by mistake. So when we unit test well our functionalities, it's really hard, if not impossible, that functionalities be broken by mistake. So if you write good unit tests, functionalities won't be broken by mistake. So does that mean that unit tests are mandatory or optional? So nowadays unit tests are mandatory to any project. Writing them represents a mandatory skill, and a Java developer must be able to also write meaningful unit tests because it's considered a must have. So, all big companies, especially, require unit tests in their code base because imagine that their code has tons and tons of functionalities that need to work as expected. So having unit tests in place brings a lot of control and also lets them know that things are working as expected. So today, writing unit tests, it's a really must-have skill. Okay, so right now I'm going to show you how to quickly start up and create a Spring Boot app. So you'll have to go to the Spring Initializer page. I'll leave you the link to this so you can also quickly go up here. My project is Maven, language obviously Java. I used Spring Boot 3 as a version. You can see in here the project metadata that I used. You can see the group, artifact, name, description, and package name. Also, you can see the packaging that I used and Java version, Java 17. As for the dependencies, as far as I can remember, I only added the Spring Web dependency. You click generate and the project will be generated for you. I already did that, and I also already added the code that that will serve us. I'll show you the two endpoints that I created. So right now you are seeing the car controller class. So in here we are having two really simple endpoints, a get endpoint and a post endpoint. So we are having a get all cars endpoint and add new car endpoint. As you can see, I used Spring Boot injection mechanism. So in here, I injected the service by constructor. So I used a Lombok annotation, required args constructor. This guy builds behind the scene, creates behind the scenes a constructor that contains all the final global variables. So this is how I injected the car service inside the car controller by constructor. So let me show you real quick how these two endpoints work. They are really pretty straightforward, but it's very helpful for us to use in our course. So we are having the get endpoint. As you can see in here, I'm having three cars: a Mercedes, BMW, and Audi. And in here I will add a new Mercedes, a G-Class. This is the second endpoint. So as you can see, I receive a 201 created, and if I call this endpoint again, you'll see that now actually I have four cars in the list, and I have the Model G-Class in here as well. Let me quickly show you the code. So you don't have to worry about writing the code along with me or something like that. I will leave you the link to my repository, and you'll see in there the code, and it will be easier for you to run it, to do some tests in there. Maybe you have some ideas, so don't worry about that. I think it's important for you to understand what endpoints are we using and how are they created here. So if we go to the car service, in here you'll see that I have a repository that's been injected the exactly same way by constructor. I used again this guy from Lombok. I have in here two methods, a get all cars, which it's pretty self-explanatory, and also I'm having a add new car method. I'm having two simple validations in here before saving the car. In here, this actually it's not an actual repository, so I didn't want to put any emphasis on creating a database, creating tables, creating a connection to that. So that's not important for this tutorial that I'm showing you for this unit test course. So I simulated a repository. As you can see in this class, I used an in list an in-memory list, I wanted to say. So this in-memory list has the three cars, and as you can see in this repository, I'm having the get all cars method and save car. So it's pretty straightforward, pretty self-explanatory. Yeah, the only thing that you have to keep in mind is that if you start the app and save a few cars, right, if you close the app and start it once again, because the list is in memory, you will begin again with the list having only these 3 cars in there. So yeah, it's pretty straightforward. And as for the car class, it's a Pojo in here. This car has 5 attributes: brand, manufacturer, year, model, number of seats, and engine capacity. So yeah, this Maven project, it's pretty simple. It has 2 simple endpoints. We are having controller, service, and repository, or yeah, simulation, let's say, of a repository. Now that we have a simple function, we have 2 simple functionalities in place, you'll get to see how we decide which classes will have to unit tests and how. So yeah, let's get to the important part. Right now, I'm going to discuss about which classes will have to unit test and why. So long story short, we are going to create unit tests for car controller class and for the car service class. Right. You may wondering, why aren't we creating unit tests for the other ones? So for the car class, this is a Pojo. So for this car class inside the model package, this is a Pojo class. Usually you don't have to create unit tests for Pojo classes. Why? In here we are having, so the Lombok data and notation is creating behind the scenes setter, getter, constructor, everything. And we know that setter and getters, for example, we know how they work. They will always work like that if you use the default, right, setters and getters, and it doesn't make sense in losing time over unit testing something that you already know how it works, and it's something very, very simple. But sometimes it can happen this, and I don't recommend you doing this, but sometimes it's unavoidable. So it can happen that you have to create a specific implementation, right, of the setters. So let's say that in here, when trying to set the number of seats, we are saying to set the number of seats only if the number is lower than 7, let's say. It's just a mere example, right? So in this case, in this Pojo class right now, in this setter class, you are having a logic, a custom logic that has to be tested in order for you to make sure that it works as you expect, right? Like I said, I don't recommend doing this, but sometimes I recognize that it's unavoidable, right? Then for the car repository, like I told you, you have to think of this class as a real repository, right? And for demo purposes, I just simulated the repository, so in order to work like one, ignore the code in here. But the main idea is that the usual car repository in a Spring Boot project would look something like this. It would be an interface that would extend the JPA repository, right? And think as this car as the entity, right? And basically Spring will create behind the scenes implementations for methods, right? So let me show you methods in here. So for example, if right now I would implement it in here, right? So let's say like usual car repository, and just do like get all car, find all cars, right? And we would use the usual car repository. We would have a lot of methods in here, right? It doesn't make any sense for you to unit test these things because they are already implemented by the framework behind the scenes. So we don't have to create unit tests for things that are implemented by the framework, right? It can also happen in the case of repositories that you'll have to create custom implementations. You'll have to write code for saving, for getting data. Yeah, so in that case, in that specific case, it's great. I think it's mandatory actually to have unit tests in there as well, in order for you to make sure that the repository works as it should. But in the moment in which you use this JPA repository capabilities, it doesn't make any sense to unit test this class. So I hope what I said makes sense, and let's get to the next step. So now we got to the important part, and that is writing the actual unit tests. So this first part is important because I will show you how I like to arrange things, how I like to arrange a unit test, to put things in that class. So I think this particularly part of the course will serve as an example for the rest of the parts that remain. So what I want to begin with is I want to start unit testing the car controller class. So basically, for this class, we'll have to unit test the method get all cars and the method add new car. So we'll have to create unit tests for that. In order to start with a more simple example, I will start by creating unit tests for add new car method. So I already created a car controller test. I usually like to do that by having the shortcut Control Shift T, and it's more simple to create a car controller class. So in the Java package from the test package, you'll see that you'll have to have the same hierarchy in order for the coverage to be seen. I'll also show you that. Okay, so let's go to the car controller test class. I like to use Mockito, and I'll show you actually why I do that as well. If you look at this car controller class, you'll see that we have an external service, an external component, and that is the car service class. So I mentioned many times in this course that when writing unit tests, we want to isolate, right? What does that mean? This means that we are only interested what happens inside the car controller class, inside the methods, inside the car controller class. We don't care what is happening in this outside, in this external component, right? So what we'll do with this one, we are going to mock it. How we'll do that? So first we'll use the inject mock and mocks annotation, and let me write it in here. And then we'll use the mock annotation for the car service. I usually like not to write in here public or private or anything else, because for me it doesn't make sense. In a unit test, this part is not important, so we don't have to take care of that, right? What these two annotation mean. So this mock annotation tells Mockito that this car service is going to be mocked. And this inject mocks annotation is telling Mockito, is telling my unit test that all of the mocks will be injected inside this car controller. Why do I want to do that? When calling car controller, I want to mock all the car services calls. Like I said, in here, I don't care how things are happening. I only care about the end result, about what is returned. What do I mean by that? Let me start writing a unit test. This way it will be a bit easier for you to understand. So let me write, like in here again, I won't add public, private. From my point of view, it's not necessary. Okay, and let's say success. So right now I want to create a unit test for the add new car method that it's going to be a success. Usually when writing a unit test, I like to split it in three parts. So it's given, when, then. in the given part, I have data that is mocked. So in here, I have data that I want to mock, data that is going to be mocked. In here, I can also build responses that I'll expect. And you'll see what I mean by that. In the when part, it's the actual call of the method that we want to unit test. In our case, basically it's this car controller that add new car. And in the then part, we are having the assertions checkings. So in this part, we verify that what we expect to happen will happen. So in the given part, I'll start by creating, so if we go here, we see that this add new car method will return a response entity that contains a car object. Also, it's important to see that the response entity will return HTTP status created, and the response entity will have a body of car, basically, because this add new car method will return a car. What I usually like to do is create a car object, right? I use the builder. And let me write everything in here. So we'll put as brand, let's say Opel, right? As manufacturer year, we'll say something like local date of, let's say minim, so we don't, okay. Then we'll have model, let's say Riva, number of seats 4, engine capacity 1.3, right? Then what we want to do is when the car service, when this method is called, we want to mock the response of that method. So logically speaking, at this point, we need to know that when this method will be called, we know that it will add a new car, and this method will return the car that has been added. Okay, so right now, how we'll do that? So we'll say something like this: when car service dot add new car with this car, so we know that it will return, it has to return the exact same car that we just been saving. So this, in this part, we just mocked the car service method that's been called in our add new car method from the controller class. So this one is pretty straightforward. It's pretty straightforward. Then in the when part, we know that the car controller will return a response entity car, and we can name this as actual response. So this is the actual response. And we'll call add new car with the same car from here. And in then part, we have the assertions. How do we assert? We'll use assert that, right? And we'll say actual response that get status code. So we know that the status code in the happy path is equal to HTTP status created. And we also want to check that the actual response body, so actual response get body, is the same with the car, right? So as you can see, the unit test is pretty straightforward. We just created a car object, we mocked the service, the car service call. We called in here the actual method that we want to test, and then we checked that what we expected happened, right? So we know that for this unit test, we want to check the happy path. Let me put a breakpoint here. And when calling this method, so the test, as you can see in here, it built a car, right? So you can see it in here. And when the actual method is called, you'll see that we managed to mock this car service method. So it's pretty straightforward. If in here, let's say that I'm changing OD, say of A5, and then I started with debug, when calling this method, you'll see that right now it just returned what I told the method to return. Now that we managed to unit test the first method, and that is add new car from the car controller, let us get to see the unit test that I added for this other method, the getAllCars method. So I will show you directly the code because the design is exactly the same. So the only things that I added are two methods actually in here, two unit tests that are testing this getAllCars, and you'll see why I did that. So the first getAllCars method, so this again unit test the happy path. So what I did is first you'll have clearly to understand what is happening in here. So this getAllCars will basically return a response entity that will contain a list of cars. So the body will be a list of cars provided by this method from the car service class. It also, the response entity contains an HTTP headers object that contains only one header that has key app name and value max app, and also the status code is 200 OK. Okay, so how I did that? Again, I split the unit test in three parts: given, when, then. I created a list of cars which contains only one car, and that's again Opel Meriva. I also created HTTP headers exactly like the ones from the car controller method. And in here, what I did was to create an expected response entity object. Why I did that? So in order for me to verify that what is actually returned is equal to my expectations, I created an object, right? And then called the actual method from the car controller. The actual response, I compare it with the expected one. Also, it's important not to miss this part. So this car service getAllCars method from here was mocked, and this method will return this list of cars. And in here we have the assertion that the actual response is equal to the expected response. If I'll debug it, and let me put also debug point here as well. So you'll see that it calls this, right? This car service getAllCars. I mocked the response of this method, and you can see that there's a list with one Opel Meriva car, right? And in here, the expected response, right? The object that I created here. I said that in order for my test to be successful, the actual response has to be equal to my expected response, which of course it happens. As for the second test that I created, it does exactly the same thing, but a bit different. Instead of me creating an expected response object, what I did was create the list of cars, create an expected HTTP headers object, and mocked again the car service getAllCars method. I called the getAllCars method from the car controller class, and then I did, instead of doing one big assertion, I did three smaller ones. So from the actual response, I got the status, which I know it should be HTTP status okay. Then I got the headers from the actual response, and I compared them with what I expect to happen. And then I got the body, and I know that the body has to be equal to this list. So again, what I did, as you can see, the test is passing. If even one small thing is different, you'll see that when I try to run the test, it will fail. So as you can see, it's actually even saying to me that, so it's saying that one assertion failed. I think it's a bit easier. Okay, so it's saying that the expected was this, as you can see it in here, right? But the actual response was this. So it was the difference in the key. So right now, we just managed to create unit tests for car controller. Again, why I created two unit tests for the same method? So I just wanted to show you that there are multiple ways in writing a good unit test. I think that you have to keep in mind some aspects like creating a simple test, that it's readable, it tests the code well, and the way you do it, it's not really that important, let's say, as long as the unit test does what it should. From my point of view, it's a keeper. So from my point of view, both of these tests are good ones. If you'd ask me, I would only keep one of them because it doesn't make sense to write two unit tests which do the same thing. But again, I just wanted to show you that there isn't only one way to write a good unit test. There are many ways. And this was just a pure example of that. So right now I want to show you how we unit test the car service class. So what we did in here was to test both of the methods that you see, the getAllCar and the addNewCar. But in here, for the addNewCar, you'll see that we'll have a twitch, let's say. So again, for this car service test, I added inject mocks and mock. So again, I'll have to mock the car repository because I want to isolate it. I want to isolate the unit tests for the car service, so I'll have to mock this guy. Then I simply created a getAllCars unit test, right, for the getAllCars method. As you can see, I used the exact same approach, the given, when, then, right? I have a list of cars. When the repository is called, it will return that list. And then I call the actual method that I want to unit test and then do an assertion. So this guy is working pretty well. Okay, things are fine here. As well for the add new car success in here, we are actually, let me delete this because it will make much more sense. We are testing only the happy path. Why I'm saying that? So as you can see inside the add new car method, I'm having some validations. So if the brand of the car is not BMW, Audi, or Mercedes, it will throw an illegal argument exception. And if the number of the seats is bigger than 5, again it will throw this kind of exception. Don't mind this illegal argument exception. It doesn't, if I think about it, it doesn't really make sense for this scenario, but yeah, just think that in here you can throw any specific exception that you want. So yeah, don't take this in consideration. But the idea is that in here we are having some validations, and if the validations fail, we'll throw some exceptions. So basically, logically speaking, if you think about it, in here we'll have three cases. We'll have the happy path, right? Things go well here, and then we'll manage to save the car. Then we are having another flow in which the first validation fails and we have this exception, and then we have a third case in which this validation is good, things are passing here, so we are good, but this validation will fail and we'll have another exception. So this is an issue when it comes to code coverage. So what is code coverage? Let me show you. We will run this unit test right now with coverage. So as you saw, we are having the first getAllCars method tested, and we are also having the happy path tested for the add new car method. So we are having a car is a BMW, the first validation is a success, the number of seats it's lower than 5, we mock the repository call, then we call the actual method that we want to unit test and do the assertion. If we go back here, you'll see we have some vertical lines. Some of them are red, some of them are green. Why that? The lines that are vertical and green mean that those lines have been unit tested. So inside the getAllCars, we managed to unit test everything. We are fine with this guy. But for the add new car, we only managed to test only a part of the method. So right now, what we need to do is test these two cases as well. How will we do that? Let me show you the unit tests that I've written. I first created a unit test for the scenario in which the brand is a different one than the accepted. So it's Opel. The first if will fail, and it will throw a new, the first validation, sorry, will fail, and we'll have a legal argument exception thrown. So as you can see in here, I'm asserting that we are going to have an exception of type legal argument exception when this car service is called with this exact same message. As you can see in here, the brand of the car must be BMW, Audi, or Mercedes. The brand of the car must be BMW, Audi, or Mercedes. So if I'm running this guy with code coverage and add to active suits, you'll see that this line 23 it's now green. This means that I also managed to test this case. The only case that remains is if the first validation passes, but the second one will fail. As you can see in here, I didn't even bother mocking the car repository call because logically speaking, I know that my code won't ever get in here if any of these validations will fail. So it doesn't make sense to mock it. If you mock it, even if you do that, the unit test Mockito will tell you that there is an unnecessary stubbing, so it doesn't make any sense for you to do that. And it will ask you to eliminate it, as far as I can remember. Then for the second one, I created for the second case in which the second validation fails, right? I created another unit test, so the brand is a good one, it's Audi, but the number of the seats, it's bigger than 5, it's 8. So we are asserting that we'll get this type of exception when the add new car method will be called with this message, the car has more than 5 seats. We'll run it again, we'll add to the active suits, and magic. Now we managed to unit test all three cases from this add new car method. So basically, only now we managed to completely unit test all the cases from this method. I'm also having in here an unexpected exception, so don't really bother that much about it. Usually I like to do this because I like to see how the framework is treating unexpected exceptions. What I did here is telling my unit test to throw an internal exception when my repository is called. So this is something unexpected. Yeah, but don't think too much about it. I just put it in there. Just don't think too much about it. So right now, as you can see, we are having all unit tests, right? We are having now all unit tests necessary for this car service class.